Good evening, everyone. Thank you so much for having me. My name is Terence Eden. I'm an editor of the HTML5 specification. Hopefully some of you use HTML5, otherwise I really am in the wrong place. I also help get 4.5 new characters into Unicode, and ask me about the half. And I also helped with RFC 7725, which of course I don't need to explain to you. Just a couple of bits of housekeeping. Firstly, this is a personal talk. This is absolutely nothing to do with NHSX. But if you would like to talk about NHSX, do please come find me afterwards. The second thing is, if I say any technical jargon or acronyms and you have no idea what they mean, please stick up your hand and ask, because I guarantee if you're slightly confused, someone else in this room is also going to be very confused, and it's my job to make you less confused. So the title of this talk is SVG WTF. Now, I said I would explain all these acronyms. SVG, Scalable Vector Graphics. WTF, Wednesday, Thursday, Friday. Someone really enjoyed that joke. So what are scalable vector graphics? Well, let's have a think about what they aren't. Let's have a think about regular graphics, which are called raster graphics. So if you use JPEGs or PNGs or even fancy WebPs, you are using Roman technology, basically. Raster images are a grid of pixels. They are a mosaic. You put one pixel here and you say it's this color, and then you put another one there, you say it's that color. And we can do all sorts of fancy maths and encoding to compress them and do stuff, but really they are just a grid of pixels. And that doesn't work wonderfully for lots of different sorts of images, and it has all sorts of weird performance things. So if you've ever had to write a web page and someone said, oh, well, for high DPI screens, for high dots per inches screens, for really high resolution things, we need the same image but at twice the resolution. Okay, great. So now we've got to load 2 different images. We've got to create lots of images. I'm going to give you a good example of why raster graphics are bad with Raster Mouse. Give it up for the easy crew. I really hope I'm not the only person who watches this. Now, as you can see here, we've got Raster Mouse and obviously Zoomer and Scratchy, and they look. Oh, someone's really into it. Now, if you've taken a photo, yeah, you probably have just a grid of pixels, and that's more or less all you can do. But let's take a look at the logo. Let's take a look at the logo of Raster Mouse. You can already see that there's some weird sort of haloing effects where we've compressed the image. And you know that when you really compress an image, you get all these weird sort of effects. I'm just going to zoom in on the A there. And this looks awful. I mean, this is just rubbish. And this is because what happens when you take a regular raster graphic and you shrink it, the computer has to go, okay, so this pixel here is red and this one here is black, so we'll have to merge them and make it a blackish red. Or if you zoom them out, you have to do some fancy interpolation, and it just ends up looking smudgy and horrible. So, you know, this image here might be fine if you're putting it as a tiny little box on your website. But if you want to take that same graphic and expand it and put it on the billboard or on a great big projector screen, it's just going to look awful. So just like President Wensleydale, we need to make this bad thing good. So that's another very good Raster Mouse reference. So I have recreated, I've just done a very rough approximation of this as an SVG, and it is very rough. What we can see here is an SVG is a scalable vector graphic. What that means is we don't use a grid of pixels. We mathematically define what the image looks like. So we use lines, we use curves, we use primitive shapes, we use colors and gradients and all sorts of things. And here, I mean, you can see this is a nicely curved shape, and we have done a gradient fill going green to yellow to red, so which is what this is, green to yellow to red, but because it's been all smushed down and then re-expanded, you just lose all that fidelity. So SVGs are awesome for many reasons, and I'm going to show you why, and while they are going to increase your performance and just make everything in the world fantastic. That is the plan. So scalable vector graphics. Does anyone know what this shape is? Please do shout out.
Circle.
5 points to Hufflepuff, it is, of course, an ellipse. Circle. Now, if we draw this as a raster graphic, what we're doing is we're saying, okay, this pixel is black, this pixel is black, this pixel is black. Something is buzzing there, don't know what that is. This one is half black, half green, and this is going to take up a lot of space, and if we zoom in on this circle that we've drawn as a raster graphic, it's going to look rubbish, and if we shrink it down, it's also going to look a bit weird as the computer tries to work out, if I take these pixels, try to shrink them. So this is how you draw a green circle in SVG. Now, so you're going to want to get your pens and papers out because this is really complicated. Oh, no, it's really simple. So stick your hands up if you've ever written any HTML or XML. Everyone, great. So hopefully this doesn't need too much explanation. We open an element, we call it SVG. We give it a namespace, which also tells us it's an SVG. Very belt and braces in SVG land, we sometimes are. We're going to open up another element. This is a circle. The circle element is called circle. Take some time if you want to write that down. The center X coordinate, we're going to give that a number. The center Y coordinate, we'll give that another number. A radius, 64, and we're going to fill it with hash 00FF00, which color is? Green. Well done. Excellent audience participation there from one person. And then we close the circle element, and then we close the SVG, and that's it, that's done. You can memorize this, and this is, a primitive shape, and you can do lots of things, but you can immediately notice some stuff with this that, some of these are numbers, and we can do maths with numbers, and some of these are fills, and we can do fancy things with SVGs, so that could be quite fun. Okay, so you've written this file, and you've saved it as whatever.svg. How do you put it into your web page? Again, really, really complicated. Take your time. Yeah, no, you just refer to it like a regular image. You should also put alt text in, for accessibility. I've just done this as a simple example, but image, source, whatever, SVG. And the great thing about SVG is it's kind of slightly old technology. This works in every browser. I don't mean every modern browser. I think from Android 2 upwards, it just works. From Internet Explorer probably has some weird quirks, but it works. Firefox, literally any browser will run this. So, okay, so you've got your images, you've got an asset, you've stuck it on your web server or CDN or whatever. Okay, that's nice. As we can see, SVGs are small. They are just text, so they compress really well, which is nice, and we can do other fancy things. So that's pretty good. That's one for web performance, but something even better. Oh, this is so cool. So in HTML5, the SVG element is a valid HTML5 element. What does that mean? Well, you can just put this directly in your markup. So, you have a div and an A and a span, whatever else, and then slap bang in the middle of your HTML, you can put SVG code. And this, again, for performance things, if you're worried about the web browser making dozens of requests to lots of different image servers to get things, no, it's just all there, it's all in line. It's fantastic. It will compress really nicely. If you redeploy your page, you can redeploy your graphics, you don't need to worry about caching. But there's some other interesting things here which you can see, which is because these are all HTML elements, we can give them IDs and classes, and with IDs and classes comes CSS and JavaScript and all sorts of weird and wacky stuff, which I am going to show you. So I run a site on, just stick your hand up if you've ever heard of the GitHub. Anyone? Yes, a few of you, good. It's called Super Tiny Icons, and there's a bunch of us, and we are dedicated to recreating popular logos under 1 kilobyte. Literally, the largest icon size we will allow is 1023 bytes, not kilobytes, not megabytes. So you can see there, the Twitter logo, 433 bytes. Now, I don't know how many times the Twitter logo is served up every single day, but I do know that they use a raster image, which is a couple of kilobytes, a couple of dozen kilobytes, and then they have a bigger one for high DPI screens. I'm not saying that I could save Twitter billions of dollars. Probably could. No, I mean, they do use SVGs, but when you are looking at your image assets, the ones which you are serving over and over again, which are, have to be in multiple sizes and multiple variants, you can actually make huge savings in downloading time, which also saves people bandwidth, which saves them money, which saves them battery life, and saves you all that bandwidth as well. So here, we've got several dozen of them, and we're looking for more. So if you're feeling handy with the graphics editor, or you just want to take a look at all the weird tricks which you can use to squish down an icon, yeah, just do a Google or Bing or DuckDuckGo or even Alta Vista for super tiny icons. Something here is really buzzy. So I'm going to talk through some clever tricks for, I'm just going to throw things on the floor. Some clever tricks for how you can really start to compress images. So SVGs are text, basically, and all right, text zips down quite nicely, but there is some really neat maths that you can do to super shrink images, which really will significantly speed up your websites. So circles, as we said, not ellipses, it was circles, I was being mean. So a while back, I'm going to pick on Twitter again. This is quite a common trope. You'll see that someone releases a new icon and they go, and we can draw it all with circles. I don't know why, but humans seem to love this. So this is the Twitter logo drawn entirely as circles. Yep, that's the Twitter logo. You could do it as circles. And I thought, could you though? Could you actually do it? And the answer is yes. There you go. This is just a series of circles layered on top of each other with different colors. You can see white and stuff. And this is just to show that if you've got a logo or any other sort of image which is a series of curves or shapes or things, you can start building it up really quite simply. You can then simplify this more if you want, but drawing circles onto a screen is mathematically and low intensity and power low intensity as well. Really can speed up rendering and downloads and all sorts of stuff. This is just quite a fun small example. The next one is X-Link. Things which have the letter X in are cool, which is basically copying and pasting. So stick your hand up if you recognize this logo. And it is, of course. This is their new logo. Now, the immediate thing that you notice about this is it is the same thing repeated 4 times. It's this little blue duck and the green duck and the yellow. Does anyone else see it as ducks? Yeah. Anyway. And so you look at this and you think, okay, well, this is a complex color logo and it's done thousands of times, how can we shrink it? What cool things can we do with shrinking? So let me show you. So we say, okay, let's have an SVG. We're going to give it a namespace of SVG. And we're also going to say we want to use X-Link as well, which is this other SVG technology. So the first thing we do is we're going to create a group. We're going to fill it with a color and we're going to give it a path ID. And then we're going to draw the shape. So that first thing is this blue duck here. And then we say, okay, use, I'll just point, use path ID A, fill it a different color, and transform it. So let's do some matrix maths on it. Let's rotate it 90 degrees around a certain point, and then do that again, but with a different color, and again with a different color. So all we're doing is we are drawing the blue duck, and then saying, okay, take that blue duck, rotate it, change color, rotate it, change color, rotate. And effectively you've cut this logo size down to a quarter of what it could be before. This is really quite significant savings, I think. There's some interesting stuff you can do with precision. So give me a shout out if you recognize this fun little fella. Tux the penguin. This logo was drawn by Jude Gibbons from on the social super tiny icons. And if I go to inspect element and zoom in, let's just, it's command, isn't it, on a Mac? Silly Macs. This is a very small logo. This is under 1023 bytes, which is pretty cool in itself. But you'll notice here, right at the top, we've put everything in a group, and we've done some matrix transformations on it. If I delete those matrices, what we've done is we've drawn a very small logo, and we've put it over there, and then we've used matrix maths to expand it and move it somewhere else, which I think is a sort of cunning way of doing things. We can, I don't know what happens if I sort of fiddle around with some of these things. We can stretch it, we can deform it, we can make Tux extra fat or extra skinny and do all sorts of weird things with it. But it means that you can take a very small logo and then start distorting it and playing around with it depending on what it is that you need to do. here's another interesting thing, gradients. So you saw previously the Rust Mouse A. This is another hopefully familiar logo. This is, of course, podcasts. Yeah, iTunes podcasts. And this goes from dark purple to light purple for reasons. If we just take a look at this, at the top of this SVG, we have a definition which is, I want a linear gradient going from this thing to this thing, and I want it to go from this color to that color. So you can see this is sort of quite a smooth gradient. If I, what's your favorite color?
Green.
Green, 0F0. Woohoo, I remembered. So when your designer suddenly comes around and says, hey everyone, we're changing the logos, we think green is more organic or natural or whatever it is designers do, you could go, oh great, so we've got to re-render all of these images. No, you can just change things once. There's all sorts of other funny things you can do with gradients, so let me just, if I change the percentage of where it comes, that's possibly not a great example, use that to 50%. You can rotate them around. And again, all of this is being done just in code, but you can certainly start doing this in CSS, and we're just going to get onto that at the moment. How am I doing for time? Okay. Just as a side note, SVGs come with a lot of metadata. So if you're using an editor like Inkscape or Illustrator, they will quite often be stuffed with metadata. You can strip all of that out if you want, and there's plenty of tools online which will do that. So if you're looking for the smallest possible SVGs, you can get rid of copyright statements, and you can change class names to being single letters and stuff like that. This is my favorite thing, SVGs and JavaScript. Heart emoji, sparkle heart emoji, no less. So it turns out, because SVGs are basically XML, you can stick JavaScript in there. Give me a shout if you think that putting executable code in an image is a great idea. Give me a shout out if you think it's a terrible idea. Okay, you're all wrong. So you can put JavaScript inside your images. This is how you do it. So you put in that X-link again, and you say script type, text, JavaScript, X-link, href, and then you just point it off to a JavaScript file somewhere else. When this image is loaded, the browser will then make a request to the JavaScript and execute that JavaScript. It's all right, it's fine. You can also, if you want, just stick JavaScript directly into the image itself. Which is fine. It's all perfectly safe. This sounds like a security nightmare, and it's probably fine. I should sound more confident, shouldn't I? What I mean is that browsers will sandbox the JavaScript, so the JavaScript will only run on the element that calls it. So if you paste your SVG just into your HTML and you've got JavaScript which runs on the whole page, then yeah, that JavaScript can affect everything on the page. That's just as normal. If you reference an image, you load the image, any JavaScript in there will only affect that image. It can't break out of the sandbox. So if you've got two SVG images, one cannot speak to another, as far as we know. But it is generally fine. I'm going to show you some of the interesting things that you can do with it. So this is a little demo what I wrote. So today is, oh, it is right, yeah, it's May the 14th, it's Tuesday, May the 14th. Let's just take a look at the page source for this. Just stick your hand up if you've ever written JavaScript. Great, so none of this is weird or freaky it's just bog standard plain JavaScript. I said, I've left my comments in there. Can I have a time, create a variable which is the day, and then get element by ID, replace it, and if I scroll down here, there's the text ID, day, it's got some text in it, and then, yeah, just replace it. I mean, this is real simple stuff. There is nothing complicated in here, but it means that you can start creating dynamic graphics. So you don't need to create a rendered pipeline for every single sort of image you want. You can have the code in the image, just doing that by itself. Are you ready for some more demos? Are you ready for some more demos? Yeah. Woo! Now, I have written none of these demos, but I am going to take all the credit for them. So this is a interactive SVG, which is on Wikipedia. It is a model of a temple of some sort. And when you click on various bits of it, oh my God, it all animates. This is brilliant. And it does stuff. And, this is, if I just, look at the source code for this, it is absolutely nothing special. It's a bunch of draw these lines, and then if I go down to the bottom, the SVG stuff is not particularly, the JavaScript stuff isn't particularly complicated. I was down there somewhere. These slides will be available afterwards. But did anyone have the misfortune to ever have to write Flash or something like that back in the bad old days? Yeah, I can see a few people weeping silently. You don't need Flash. You don't need stuff like this. This will work. I mean, this will work on your phone, your iPhone, your tablets. This is just there. It works. This is all bog standard JavaScript and SVG. And we can do some other interesting stuff with it. So this is, I really like this one. This is a 3D clock. And this is pseudo 3D. You could probably do this with the canvas element or some of the stuff like that if you wanted. But if I just take a look at the page source again, this is not a long, complicated thing. There's a little bit of matrix maths in there, but not a huge amount. And all of a sudden you can start to see we can make these amazing sort of interactive, cool 3D things which run sort of more or less at the speed of the browser. And this is going to be important in just a second. So this one here, I thought, as we're in a sort of journalisty office, I'll show this. So this is, everything you're seeing here is an SVG. It's an SVG, there's some CSS, there's some JavaScript all separately, and we can start to, make, I could just play with that all day. No, I'm just going to keep doing this. So you want to start making interactive things. Well, you all know HTML, you all know CSS, you all know JavaScript. You can start building these things. And there's a whole bunch of open source libraries which will allow you to create these things relatively easily. And the performance, as you can see, is absolutely fantastic for interactive content. I'm going to show you my, I think, penultimate demo. Which sort of just ties in everything. So these are, how many of you have like GIFs as like loading animations? And GIFs always look crap, and they've got limited color palettes and they're big, and we're meant to be moving to WebMs and H.265s and AV. I mean, yeah, you can render all of your loading GIFs as videos and stuff like that, or you can just use HTML and CSS. And these CSS here, if oh God, backwards scrolling is the worst. You can see that these have, hopefully you can see that there, the SVGs have animations built into them. So if I take this first one and I change it to, I think, 5 seconds rather than, so you can now see that is now running at the speed of the browser, so I guess 60 frames per second or something like that. You can start dynamically altering all your spinners based on whatever it is that people in your office say. And you want to change the color of all of your spinners because the corporate colors have gone from red to green or from green to blue. It is as simple as one line. Well, that looks horrible. It is as simple as one line of CSS changes and all of your icons can change. You don't need to build complex rendering pathways. SVGs are first-class elements within HTML. They are supported everywhere. They are fast, they are small, they can do all sorts of amazing things. And those of you who are quite observant, yes, I do want to leave the page, will notice that this entire demo is an SVG. This isn't an HTML page with an SVG. This whole thing is an SVG, which you can download from my website and play around with. And I just think SVGs are fantastic, and I think you should start using them. Thank you very much indeed. Cheers. I will also say, if you visit my website, which I do encourage you to do, edent.tel, then everything on there is an SVG as well, and you'll see how fast and awesome it loads, and it's got animations and cool stuff like that.